This video belongs to a series of videos in which I attempt to intuitively bring out concepts related to multiplication in the world of natural numbers. You may be someone who already knows how to multiply two natural numbers, but is curious to find out why the method works the way it does. Or you may be someone who is totally new to the multiplication algorithm. Either ways, you have come to the right place. In previous videos, we had looked at what happens when the multiplier is a single digit number and also what happens when we multiply by 10. In the current video, I will attempt to bring out what happens when we multiply by numbers ranging from 11 to 19. As always, I will take an example. Say, I want to find out what is 13 times 253. We know that this can be thought of as 253 plus 253 plus so on, that is 253 added to itself 13 times. This repeated addition can be tedious to do in general, so we need something better. If I know the multiplication table for 13, that is, if I know what is 13 times 1, 13 times 2, 13 times 3, and so on till 13 times 9, I can follow the method that I used when my multiplier was a single digit number. For that, I will first write my multiplication problem like this. I have 3 units, so I need to find out what is 13 times 3. But from the multiplication table for 13, I know 13 times 3 equals 39. I have 39 units, I retain 9 units and carry forward 30 units as 3 tens. Next, I have 5 tens. So I need to find out what is 13 times 5. Again, I happen to know the multiplication table for 13. So I know that 13 times 5 equals 65. I have 65 tens. Adding the 3 tens that I carried forward, I get 68 tens. Again, I retain 8 tens and carry forward 60 tens as 6 hundreds. I move on to the 2 in the hundreds place. I need to find out what is 13 times 2. Again, from the multiplication table for 13, I know that 13 times 2 equals 26. I have 26 hundreds. Adding the 6 hundreds that I carried forward, I get 32 hundreds and I am done. Our multiplier could have been any number from 11 to 19. In fact, as we progress further in this series, our multiplier could be any number in general, and it is obviously not possible for us to memorize multiplication tables for all numbers. So let us see if we can get a different method to solve this problem. To arrive at this method, I will begin by writing 13 times 253 as 3 plus 10 times 253. Multiplication distributes over addition. So this is equal to 3 times 253 plus 10 times 253. Now again, I'll write my multiplication like this. I'll first find out what is 3 times 253. 3 times 3 is 9. 3 times 5 is 15. I'll retain 5 tens and carry forward 1 to the hundreds place. 3 times 2 is 6. I'll add the 1 which I have carried forward to get 7 hundreds. Next, I need to find out what is 10 times 253. This is just all the digits of 253 shifted one place to the left and a 0 put in the vacant units place. This can also be thought of as putting a 0 in the units place and then writing the result of 1 times 253 to the left of the 0. I have done these two multiplications and captured their result here. I now need to add these two. 9 plus 0 is 9, 5 plus 3 is 8, 7 plus 5 is 12. I retain 2 hundreds and carry forward 10 hundreds as 1000. Adding the 2 in the thousands place to the 1 which has been carried forward, I get 3000s, and as before my answer is 3289. Now let us examine the method that I followed. I took the digit in the units place of the multiplier and multiplied exactly as I would multiply when the multiplier is a single digit number. I then proceeded to multiply by the digit in the tens place in the same way, but before that I put a 0 in the units place. I then added the results of the two multiplications to get the final answer. We now have a generic method to solve multiplication problems involving multipliers from 11 to 19. In subsequent videos, I'll move on to double digit multipliers in general and then on to the generic process of multiplication in the world of natural numbers. I hope you found this video useful. Thanks for watching.